So we're going to start with our Unit 10, Acids and Bases, and the first thing that we did in this unit was we looked at some cartoons to kind of learn some things about acids and bases. So the first question we have is list 3 things that have acids in them, list 3 things that have bases in them. So you have this cartoon in your packet, and so it comes from the book The Cartoon Guide to Chemistry, and I highly recommend checking it out. But it says acids, sour and aggressive, are everywhere. They're in salad dressing, rainwater, car batteries, soft drinks, and your stomach. So we can list those 3 things as 3 things that have acids in them. So salad dressing, rainwater, car batteries, and soft drinks or soda. And then it says to list 3 things that have bases in them. So let's pick up where we left off. They can burn, corrode, digest, or add a pleasant tang to food and drink. Bases, bitter and slippery, may be less familiar, but are exactly as common as acids. You'll find them in beer, bufferin, soap, baking soda, and drain cleaners. Okay, so those are some things that we're looking for. So let's see. 3 things have, let's see, beer, drain cleaner. It also said soap. Okay, really all cleaning products have bases in them. And before you go thinking that all alcohol is basic, beer has bases in them, but wine is acidic, so alcohol can vary depending on the type. Now, question number 2, what are 3 words that describe what acids do? What are 3 words that describe what bases do? Well, if we look at our thing, we can see words that say that acids can burn, they corrode, they digest. Okay, these are verbs that talk about what they do to other objects, right? And bases, okay, they do very similar things, okay? They can burn, corrode, and digest. So we're just going to use those words here. So burn, corrode, digest. These are things that can happen. And bases specifically can be used to clean things. One reason why bases are in drain cleaner and acids are not is because bases and acids can both like eat through clogs and drains, but bases will leave your pipes alone, whereas acids will react with the metal in your pipes. And so that's just a fun fact. Okay, so let's continue to read our comic. Okay, it says acids and bases are sometimes useful, often harmful, and always a great opportunity to play with equilibrium constants. Now, this you do not know yet. You don't know what equilibrium constants are. And in fact, we're not really going to talk about them much in a general chemistry class, at least in this county. And so we can see that this girl is like, oh, goody, yay, we're learning about acids and bases. And we see these things that say, don't touch, caustic. Okay, that means like harmful. Okay, it can burn through like your skin and things like that. Toxic, danger, warning, poison, caution. Okay, these are words often associated with acids and bases. Okay, and then let's continue reading the comic. It says acids and bases are intimately connected via protons. Okay, via is another way to use that word is to say through. Okay, so this means they're intimately connected through protons, and IE is something Latin, but it really means, in other words, hydrogen ions. Okay, so it's saying protons are also called hydrogen ions. Now, the reason why this is true is because if you look at hydrogen on the periodic table, it's number 1, and it has a mass of 1.01. And so this tells you that an atom of hydrogen has a proton in the center and one electron going around it. And so if you take away that electron, okay, and now all you have is a proton, then that's why H plus is also a proton, because that's literally all that's left if you take away the electron. So let's continue to read what it says. It says an acid is any substance that throws off protons. The stronger the acid, the more easily it sheds H plus, or protons. So you can see in this picture, it's got the proton, this little acid kind of person has a proton, and the strong acid, the proton is kind of coming off of its head. Okay, it says since naked protons are wild, aggressive creatures, strong acids are very reactive. Okay, so they're very reactive. And it says a base is any substance that takes up protons. Okay, so a base is going to take up the proton. So this is the base, and it's receiving the proton, or the H plus. Okay, bases generally have an exposed electron pair where a proton can nestle. So if you have two electrons, then your proton can come in between them. Okay, and that keeps the negative charges away from each other. And it says the stronger the base, the more strongly it wants to bond to a proton. So this weak base is like, maybe I want that proton, and the strong base is like, give me the proton. Okay, you can see even the body, it looks like a stronger body. It says, as you can see, an acid is just a proton attached to a base. An acid and base paired in this way are called conjugate to each other. So you can see if you take a base and you add a proton to it, you end up getting an acid. And so bases and acids are pairs if the only thing that's different about them is an H plus. And so by definition, the stronger an acid, the weaker its conjugate base, and vice versa. So that means this right here, a weak acid has a strong conjugate base and a tightly bound proton, and the strong acid has a weak conjugate base with a loose proton. Okay, so these protons, they are staying where they're supposed to be. This proton, it can kind of move around. So let's look at those 9 questions that we had. So with those 9 questions, okay, it said according to the cartoon, a proton can also be called hydrogen ions. And it says, what is the symbol? Well, the symbol is an H plus. Okay, and it says, what is the definition of an acid? Well, according to the article, or the cartoon that we read, the acid is something that gives away protons, or H plus, right? And a strong acid, well, in the box in our cartoon, it talked about how strong acids are very reactive, and it says that the stronger the acid, the more easily it sheds H plus. So that means strong acids are very reactive and give away protons easily. Okay. And number 6, what is the definition of a base? Well, it said that the bases are the opposite. They accept the H plus. And the strong bases bond, they bond strongly to the H plus. Meaning, if you have a strong base, it is not going to give up its proton very easily. It wants to hold on to its proton strongly. And number 8, what does it mean to have a conjugate acid-base pair? It means a pair that is different only by H plus, right? That was the only difference. One had H plus, one did not have H plus, right? And you could either take away or add an H plus to make the other. And number 9, well, a strong acid have a strong or weak conjugate partner. So if I am a strong acid, it said the stronger the acid, the weaker its partner. So strong things, so strong acids partner with weak bases. And so that also means that strong bases partner with weak acids. And so now we're going to look at the next kind of section and the next cartoon. Okay, so it says to look at the acid-base pairs and to answer these questions. Okay, and so what we're going to do is we're going to read through our next cartoon, which is here. So it lists out our acid-base pairs. Okay, and just as a reminder, the word conjugate means partner. Okay, and you've heard this in lots of other kind of words. If you hear words that kind of sound like conjugate, it probably has to do with something dealing with some sort of partnership. But if we look at the first thing, we see that our acids are in the left column, bases are in the right column. And if they're in the same line, that's saying that they're partners. So these two things are the first partnership. And here, this is the strongest acid, and this is the weakest base, okay, in this list at least. And so they want to show that your strong acids partner with weak bases and vice versa, which means that our strong bases would be down here. This would be a strong base, and this would be a weak acid. We're going to go through, and one big thing about chemistry is that there's always patterns. And so we want to look. In sulfuric acid, there are 2 hydrogens, and in bisulfate, there is only 1 hydrogen. So the difference is H+. And if we look at the second one, hydroiodic, it's a really friendly acid. It likes to say hi. That's just a little fun little joke there for you. Hydroiodic acid and iodide are different only by a hydrogen. Hydroiodic has 1 hydrogen, iodide has no hydrogens. So again, H+ is the difference. And if we look, we can see that all of our acids start with hydrogen, with the exception of vinegar, but sometimes the hydrogen is written at the front just to make it match. In this list, it's not. Carbonic, ammonium, again, is an example where the hydrogen is at the end. And then this hydrogen, hydrogen, and water. Okay, so we can see all the acids start with hydrogen. We can see the difference between all of the acids and their partners is they're exactly the same, but one has H+ and one is missing a hydrogen. So the acids have an extra hydrogen compared to the bases. And another thing that you might notice is that water is listed as both an acid and a base. And we're going to talk about how water can behave as both. But this is a key thing to note, that this pattern is always there. So it always starts with hydrogen. Your base is always your acid minus a hydrogen. Okay, so that's the connection there. So let's go back to those questions then that it asked us. So the first pair of sulfuric acid and bisulfate, we said that the only difference was H+, and that was the same difference for hydroiodic and iodide. And so all of the pairs on the page follow the same pattern. So yes, they all follow the same pattern. And based on this, so based on this pattern that we see, it says look at the equation below and circle the conjugate base for HNO3. Now because it starts with H, this tells us it's an acid. Okay, but we can also confirm, because when we look here, we see HNO3 here, and we're looking for its conjugate, remember, which means its partner, should be very similar, but have a different, or it should be missing a hydrogen, because that would mean the H goes away. And so we can see that NO3 here would be its conjugate base. Okay, and this is the acid, right? So the only difference between those two is a hydrogen. And then number 5 says, was the conjugate base that you found in question number 4 on the same side of the equation? And the answer is no, it is a product, right? If we remember, anything on the right side of the arrow is a product, and anything on the left side of the arrow is a reactant. So they're written on opposite sides, and that's because a chemical reaction has to happen. You have to get rid of a proton or a hydrogen. That has to move somewhere, and so that is going to be a chemical reaction. Okay, so this was just kind of going over the cartoon, and we're going to stop the video there, and I hope that clears that up a little bit.